All right. So thanks a lot. Thanks everybody for joining. So I'm going to talk about a compact narrowband tunable optical filter. About the company, TeraXion, we're a company based in Canada, now part of Indie Semiconductor, and we're proud to also present our sister company, Exalos, and now TeraXion and Exalos together, we're the photonic business unit of Indie. What we have in common is that we've always focused in delivering um, photonic components. So really, yeah, specialized at the component level. We're a proven supplier to the photonic industry with more than 1 million components sold up to date. And in terms of technological expertise, I'm focusing on interaction here, delivering solutions for different applications, both fiber Bragg grading, low noise laser, low noise electronic locking loop, optical phase locking loop expertise. And today's topic, we're really focusing on our fiber Bragg gradings expertise for filters, also electronic and packaging. So we have a tunable filter platform based on best-in-class thermal management to stabilize and tune the central wavelength of those filters. And to the question why using FBGs for filter functions, there are many benefits, and the main one being of the ability of designing high performance filters that can be tailored for specific needs. So we're able to write grading at any wavelength between 700 nanometers and 2.1 micron. We can also tailor custom bandwidth, narrow bandwidth down to 2 gigahertz for a single reflective band filter, and also a notch filter ultra narrow from tens to hundreds of megahertz bandwidth. And we can also optimize the profile for flat top steep edge isolation, for example. And in terms of functions and applications, those filters are often used for carrier suppression or sideband isolation in microwave photonics and radio frequency over fiber. Another example is wavelength selection in frequency comms, carrier suppression, signal isolation, and ASC filtering in brilliant sensing, or signal isolation in quantum key distribution. So here are a few examples where a really narrow band filter can be of interest. And in terms of profile, this is an example of a single narrow reflective band filters, few tens of gigahertz bandwidth. And what I was saying, typically designed with steep edge and flat top. We see the profiling reflection and transmission. You can use these filters in many ways. Ways to focus on the signal isolation, so reflecting the signal. Then you typically package the filter with a circulator to have access to the signal which has been reflected. Or you can also focus on suppressing the carrier. So here we reflect the carrier. So if we look at the transmission, so the isolation from a transmission point of view, the target is transmitted. You don't need an isolator. You have access to the signal directly. And in transmission, you're able to reach isolation of more than 50 dB. Another example of grating that we can write, I've talked about the 35 to 500 megahertz notch filters using a phase shift. I'll go quickly on this one, but it's often packaged into the tunable platform to get the ability of align with high precision, this really narrow notch. It's also the possibility to combine two fiber Bragg grating together to reach isolation in the 80 dBs floor that is not shown on the figure here, but really combine the isolation of two FBGs. And finally, another one of interest is the asymmetric filter. So then we'll really optimize the design to work on a specific edge. And here is an example of such usage of asymmetric filter. So optimized for the steepest edge. Left edge on this example, we have a carrier with a sideband few gigahertz away, and we want to really isolate the signal from the carrier, suppress the other sideband, maybe some ASC noise here. And it's often packaged with the tunable platform because we really want align or hedge on the sweet spot here. And what the tunable platform gives is best-in-class stability and also the ability to have a precise and dynamic alignment with 2 picometer resolution. So the TFN itself, what it is, it's a temperature-controlled FBG, tunable over 60 gigahertz, 2 picometer accuracy, really high stability, and also it's suitable for all types of gratings. And what's new, what we're releasing today is a new compact module that gives access to the transmission port. So we didn't have this before. Our reflection plus transmission TFN was much bigger. It's offered with fiber pigtail input outputs. We can also characterize those pigtail. It's offered with or without circulator. We have the ability to co-package the circulator within the module. For SM fiber, with PM fiber, the circulator will be integrated outside the package. And we also have the ability to integrate 2 FBGs in this small module for extra isolation. And here we have the 3 TFN. Maybe just a last word here, conclusion slide. It's really a versatile platform for high-end performance FBGs. So we have multiple package options to fit your needs. TeraXion, we've been delivering high-end FBGs for more than 25 years. We know what we do. We have proven simulation tools and grading inscription method, and also best-in-class packaging and thermal control. So if you have any really challenging filtering need, you need an optical fiber filter, call us. We may have a solution for you. Thanks a lot for your attention.